imagine the coordination needed to perform these complex movements. Which part of the body is working hardest? The real action happens inside the head. The brain is only a tiny part of you. It's smaller than, say, this cauliflower. But the cauliflower doesn't do too much. The brain, on the other hand, is in charge of everything you feel and do. This control is possible thanks to a network of tiny pathways called nerves, which run beneath your skin. And all over your body, tiny electrical signals are hurrying along the nerves towards the brain. For example, the hands touch the bar. Quick as a flash, they send off a signal to the brain. The message reads, "This object is cold. It's round, hard, and smooth, and we're holding on to it." Even though the process actually takes only a microsecond. We can imagine the signal's journey through the nerves. When the signal reaches the brain, it finds a mass of nerve cells, or neurons, waiting for the message. Long fibers, or dendrites, reach out to pick it up. As the signal jumps from one neuron to another, it crosses a synapse, which in Greek means handshake. It's as if the neurons shake hands. As this happens, the gymnast gets the message from the fingers. She feels the bar. There are over 1 billion neurons in one brain. If you took a second to count each one, you'd be counting for 30,000 years. This process happens constantly, at lightning speeds, all over your body. Millions of electrical signals carrying messages are zooming through the nervous system and into the brain. This body-to-brain communication is being studied at the USC Medical Center. Electrodes attached to a patient's head measure the electricity in her brain.
Is my friend going to be okay?
She's going to be just fine.
What are you doing?
I'm monitoring her brainwave activity. See how busy the brain is? Now close your eyes, Yana. Your brain is always responding to the things you see, anything you feel, or even the things you hear. Open your eyes, Yana. See how the brain waves change in response to opening your eyes?
So, the brain's first task is to receive all these sensations from the body. Its second task is to process the information and send instructions back out down the nerves. Maybe it wants the feet to run. It sends out the command. The brain tells the knees when to bend, the legs how to spring, the hands where to land. Before you make any movement, your brain performs 1,000 calculations about the speed and direction of the move. Of course, you don't think about how to run. It just happens. But no matter how quickly you move, your brain has planned and even rehearsed the movement in a fraction of a second. We don't think about how to speak or form words either. We just open our mouths and talk. When we're hungry, we simply eat. But without the brain, we couldn't say a single word or take a bite of food. Even tasks like digesting food, circulating the blood, or breathing are carried out by the brain. A special part called the brainstem takes care of many of these unconscious tasks.
Hey, Matt. Matt, wake up.
Sounds are carried along nerves which lead into the auditory cortex. This part of the brain
Matt.
hears.
Wake up. Wake up. Hey. Come on, Matt. Wake up. Let's go in. Come on, let's go.
The visual cortex handles everything we see. But when the brain has to decide, what do we do now? The whole cerebral cortex is involved in the decision. But what if something goes wrong with this complicated system? Most of the time, Jana is a normal, healthy girl. But sometimes, for short periods, her brain waves change dramatically. This is because she has a rare brain disease called epilepsy.
You see how the brainwave activity changes when she's having a seizure?
She okay?
Yeah, she's okay, but she just doesn't know what's happening. Jana, can you hear me? Do you know where you are?
Epilepsy, like many other brain diseases, is now controllable thanks to drugs produced by medical research. But despite scientific progress, there's much we still don't know about even a simple rat brain. Dr. Hernandez, investigating these specimens, has discovered the cause of a stomach disease. He found out that chemicals produced in the brain actually cause stomach ulcers, in humans as well as rats. With this knowledge, he can develop a cure. Like individual members on a team, each part of the brain and body has a separate job to do. But they must collaborate to produce results. It's no good telling your feet to run if your eyes aren't looking where they're going. This coordination, this teamwork between millions of tiny elements, is what makes the brain such an effective and marvelous part of who we are.